All right, my Algebra 2B students, we are up to the second lesson of this trimester. We're moving right along. The thing about this particular section, 6-2, the title's called Properties of Radicals. And this particular section, believe it or not, and I'm not going to do this all the time, but I'm going to break this particular section up into 3 days. I'm supposed to cram all this into your minds in one lesson. I'm not going to do that to you because it is an enormous amount of information to cover in one day. So I'm going to breathe. I'm going to break this section up into 3 chunks, and you're going to pay for that later, though. Okay? So I'm being nice to you now, but there's going to be an effect. Anyways, let's get this started, okay? So you guys are familiar with what I call perfect square roots. Why are they called perfect? Well, because the sides of the square. If you remember my lesson on square roots, we're talking about the area. That's the area, area of the square, area of the square, area of the square, area of the square, and I just made a big one, area of the square. And it's asking for what is one of the sides of a square if the area is 900. Well, that would be 30, because 30 times 30 is 900. Square root of 36 is 6, square root of 25 is 5, 4, 3, 2, 1. Now, at this point in the lesson, I need to take a moment and also show you the difference. See, notice if it's written like this, you only give the positive answer. And that's just one of the unwritten rules of algebra. They want what's called the principal root, which is considered the positive one. But if it's a problem like this, the instructions are going to be different. See, the instructions for these would be simplify, and you only give the positive what's called the positive root or the positive answer. Now, if you put plus or minus 6 for that question, even though they only want the positive one, there's no way I could mark it wrong because you're not wrong. They only want the principal root, which is the positive one. So you're just getting a little extra. However, if the problem says find all the solutions, plural, and you got to remember my little jingle. Bada boom, bada bang, what? What? Do the right thing. So we get plus or minus 2. Now here's the difference. If I just say this is 2, and math teacher's in a bad mood, it's like, no way, Jose, you got that wrong. If someone's in a semi-bad mood, or if they're just doing the right thing, they're going to give you half off, because you only found half of what is true. Plus or minus 2. So remember, if it's written like this and it says find all the solutions, it's asking you to find all the solutions. So bada boom, bada bang, do the right thing helps you remember that there's 2 answers for problems like this. You did these in the previous lesson. I just want to remind you of the unwritten rules, okay? This one, okay? This one's just a sample that I made up for you so that you can kind of understand math. So first of all, what is the square root of 4? It's 2. What's the square root of 25? It's 5. What's the square root of 100? It's 10. So now let's experiment. First of all, is the square root of 4 times the square root of 25 equal to the square root of 100? And we could say, well, yeah, but what I'm going after is this. What is 4 times 25? Well, that's 100. So what I'm saying is, if you think of this equation going left to right, the rule is it's okay to multiply square roots. In other words, 4 times 25 is 100, and mathematically it just works. But there's another rule, and the rule is if I go this way, math is telling me I can take a square root and I can break it up into 2 factors. In other words, 25 times 4 is 100. So there's always 2 ways you can read a mathematical equation or sentence. You can read it left to right, which we English speakers are used to, and that's how we typically read. But we got to understand, math is not bound by the rules of English. You can read it right to left also. With that in mind, notice the title, Non-Perfect Square Roots. See, the square root of 28, if I took that in my calculator, I'd get 5 point something. In other words, the square root of 25 is 5. The square root of 28, the area is a little bit bigger, so the side would have to be a little bit bigger in order for the area to be 28, okay? So what do we do with this? Well, if we take our calculator and we go, all right, it's 5.2. That's not wrong. It's just not what Algebra 2 wants you to do. Algebra 2 wants you to break it up into the product of 2. Remember, we said that that's mathematically okay. You can take a number and break it up into the product of 2 different square roots, and that's what we're doing. But the thing is, the first one should come from this list, and it needs to be the largest possible one. In other words, we go up the list or down the list. 1, don't worry about that one. That's never going to really help you in this discipline. 4, does 4 go into 28? Yeah, it does, but don't just put it there. Keep going. Does 9? No. Does 16? No, 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 no. So we could put it there. But then we ask ourselves, 4 times what is 28? That'd be 7. Now think for a second. Listen very carefully. What is the square root of 4? Well, that's 2. What is the square root of 7? Well, that's going nowhere. Why do I know it's going nowhere? There's nothing from this list that goes into 7 evenly. Now, you guys might think I'm super weird, and that's okay, but I'm going to teach you something that's going to have a theme throughout this whole trimester, so don't miss this little point. You're going to hear me refer to this as oil, and I'm going to refer to this as oil. If I take a bucket of oil, half full, and I pour some water in it and stir it, it won't mix, okay? That's true for this. You cannot make this the square root of 14. This times this does not equal the square root of 14. It just doesn't, so don't go there. Now back here, we got oil and oil, so we said you can multiply them, okay? Or we could say it's water and water, and so they mix mathematically. Here, they do not mix, okay? Now, with that being said, here's my oil, here's my water. In other words, don't you dare multiply the 3 times the 48. It just doesn't work. Now, the 48, though, I'm going to break the 48 into 2 different products. So this and this. That 3 just comes along for the ride. Now watch what happens. Does 4 go into 48? Yes. And I want to put it there. But wait a minute. If I keep going, does 9? No. Does 16? Yes. So that's a 16. How many times does 16 go into 48? 3 times. Now watch what happens here. The square root of 16 is 4. So now I got 3 times 4 times the square root of 3. See, now I got oil, and I got a little bit of oil, and I got some water. See, the oil can mix. So I get 12 square root of 3. And that's how you're going to handle these types, okay? Now, a couple other things, and we're almost done with this pre-lesson. The square root of 2 times the square root of 2, if we go back to this rule, does that equal the square root of 4? Yes, it does. What's the square root of 4? 2. What's the square root of 3 times the square root of 3? Well, technically, it's the square root of 9, which is 3. Now, what I'm going to do is show you something. Now, I'm going to erase this little line, and I'm going to rewrite this as the square root of 3 squared. And I want you to repeat after me at home, in front of all your brothers and sisters and everyone in the dining room. If you square a square root, the roots fly off. In other words, this and this cancel, and your answer is just 3. Square root of 2 times the square root of 2 is the same thing as this. And there we have it again. If you square a square root, the roof flies off. You're going to hear me say that a lot, okay? Now, why am I showing this to you? Well, I'm getting you ready for these 2 sample problems. It'll be the final sample problems of this lesson. Look at this guy. 2/3 times 7/7. I bet you a lot of you would go, oh, that's 14 over 21. And then you're like, what does that reduce to? And you go, 7 goes into that twice, 7 goes into that 3 times. And you're like, well, what'd you do that for? Look, what is 7 over, forget that method. What is 7 over 7? It's 1. What's anything times 1? Itself, okay? So when we multiply the 2/3 times the 7 over 7, we made it 14 over 21. 14 over 21 is the same thing as 2/3. They just look different. Keep that in mind. Now, if you have square roots in the denominator in good old Algebra 2 and Algebra 1, pre-algebra, that is considered not simplified, okay? I teach a little life lesson for parenting down the road, and it is when you're parenting, never, never leave your radicals in the basement. Never leave your radicals in the basement. Who are your radicals? Your kids and their friends. You leave them in the basement, bad things happen. Okay, just going to leave it there. How do I get rid of the radical in the basement? Well, I'm going to take advantage of this rule, and I'm going to take advantage of this rule. I can multiply anything I want as long as that thing is equal to 1. See, I'm going to change the way it looks, but I'm not going to change what its value is. So, how do I get rid of that square root of 2? I'm going to multiply it by another square root of 2. However, if everything in this parentheses needs to equal 1, I need to put a square root of 2 in the top also. Now watch. If I multiply straight across, if I square a square root, the roots fly off, and then I get 4 times the square root of 2. Now, a lot of students just say, I'm done, good, I got the radical out of the basement. And that's true, you did. But this can be reduced. So I say, check your oil. Okay, 4 divided by 2 is just 2. That's what this is, and then I have a square root of 2 along with it. So just to make sure you're getting this, now I have a 3 over a square root of 3. Can I cancel these 3's out? I sure want to. No, because this is not a 3. It's the square root of 3. So you can't think of it as a 3, okay? So what I'm going to do is I'm going to multiply it by something that equals 1. But what times the square root of 3 makes the root fly off? Itself. So I'm going to go ahead and take the radical out of the basement. That's good parenting, by the way. Get them out of there. But I need to also multiply the top by the square root of 3. So this times this would be 3 square root of 3. Check your oil. Sometimes that will reduce. If it doesn't reduce, just leave it. But this time it does again. So I'm left with the square root of 3. The only thing I haven't said to you yet are problems like this. Okay? And a lot of you will just instinctively, like a robot, you will go square root of 3, square root of 3, because that's what we did over here. But wait a minute. This is water up here, and this is water down here. Water and water can mix. What do you mean it can mix? Well, this is division. So this is going to equal the square root. How many times is 3 going to 96? 32. Okay? Now, way easier if you notice that those will mix, because now I can take the square root of 32, and I know I'm all over the place, but I'm going to break that into the product of 2. I'm going to go way over here and go down my list. 32, does 4 go into 32? Yeah, but wait, does 9? No. Does 16? Yes. That's going to be 16 times 2, which is 4 square root of 2, and there, I just simplified this weird looking thing quite easily. All right? There's your pre-lesson. I'm going to call this part 1 or day 1 of unit 6-2. Good luck.